Hello and welcome back. I want to go through the last two examples of the nonlinear regression and give you a chance to try them and make sure you can do them yourself. So the example provided here I pulled it out of I think it was a 3U biology or 4U biology book, and it's just a simple table showing bacterial growth. So question A says to create a scatter plot. So at this point you might want to pause and enter the data because I already have it entered on my calculator. Okay, once you have that done, then you can move on, and again we want to adjust the window. So I see that my time frame here in hours, it's only in the first 7 hours, so my window I'm going to adjust it from 0 hours to 10, and then 0 as my minimum, and now I see that I get up to 475, so I'll go 500 just because I like even numbers, and then I go ahead and graph it, and there's my points. So when you go back and you're looking at the different types of graphs that are out there, you make a determination as to which way or which one you're going to try, and at the end of the day you have the R² value to determine what value you want. So there's my scatter plot, that's my A part. So B part, determine the type of regression. Well, we can rule out a couple. I know that it's going to be some form of smooth curve. So my bet or my guess at this point, and I'm just going to tell you what my thoughts are, I'm going to try quadratic. So I'm going to have an R² value, and I'm going to try exponential. I have an R² value. Now, people who have taken the biology, you should be screaming out the answer at this point in time because you should know what bacterial growth follows. But for us that don't, we're just going to go through the process. So have the calculator up, I go to stat, and I'm going to try quadratic regression to start. I hit enter, and it's going to give me the equation, the quadratic equation, but I'm more worried about R² at this point. So R² is 0.996. So 0.996, 0.96. Pull up the calculator again, and I'm just going to go through it, and this is the process you generally go through. You narrow it down to 1 or 2, or sorry, 2 or 3, and then you go from there. So now I want to try my exponential. So that's number, I guess that's an A, is it, or a 0? Number 0, exponential. I'll let it run through there and see what happens. And now I have 0.995. So 0.995. So when you compare the two, it looks like the quadratic regression is actually better, which goes against my predictions. I thought that we'd be looking at, definitely looking at an exponential growth. So just doing the quadratic regression one more time. Yeah, the R² is 0.996, so it's just a little bit better for the provided data. So there we go. So we know that it's a quadratic relationship. So determine the type. So based on analysis, it would be quadratic regression, or quadratic function. All right. How do you know your choice was the best option available? So, C part. After looking at both quadratic and exponential, the R² value was higher with quadratic. D part, determine the equation. Not too difficult because you just need the graphing calculator display screen. It's all there for you. So there's the quadratic. That's why I did it again as well. So do a screenshot there so I can bring that in. And just making a bit of room. Okay. So the equation will be, and it's all there for us, y equals. The A, B, and C values are all there for us. So 17.4x² minus 63.8x plus 66.4 as the constant. And again, I can't emphasize this enough. You need to be able to tell me what y and x represent. So y is the bacteria population, and your x value is our time in hours. So then to finish this question off, when we're looking at E, predict the population after 24 hours. So we're going to substitute 24 in for x, and we get y equals 17.4 multiplied by 24 squared minus 63.8 times 24 plus 66.4, and now you just plug that into a calculator and find out your final value. And I get 8557.6. Oops, 8557.6. Now, please don't be the person that leaves 0.6 of a bacteria out there. Round it. So therefore, after 24 hours, there will be, and it's key here to put approximately. Why do we use the word approximately in our statement? Well, we just created a line of best fit, not the line that it will follow. So it's an approximation. It's always approximation. So it'll be an approximately 8,558 bacteria. All right, so keep that in mind. So in this part, there's no critical analysis at this point because we're just practicing with the dealing with nonlinear relationships. So keep that in mind. We're going to do a critical analysis coming up a little later on, so you get a chance to do that. Okay, final example here. If you want to enter the data into your calculator, because I already have, and we'll go from there. All right, so in this particular question, the following is taken from a lab, and what's happened here, we've basically dropped something. The information's a little scarce here, but something has been dropped inside a lab, and the time has recorded how far it's fallen. So it's a physics application here. So create a scatter plot, so we're back to that. I'm just going to make my calculator a little bit bigger again. It seems to have shrunk. Okay, and we can go through and do our analysis. So you hit your stat. Sorry, our window is the first step, so it's 1 to 7 is fine. This time going from 0 to, say, 250. And when I look at the graph again, it looks like I have the same decision I had to make as the previous one, and that is it quadratic or is it exponential? They seem to be fairly similar when you look at them or compare them. So there's my scatter plot for A. Of course, you can just give yourself a rough sketch in your note or in your home when you do the homework, just to remind you what the shape was. Determine the type of regression. So again, you narrow it down. You don't want to go through all of them. So it's either going to be quadratic or it's going to be exponential, and I'm going to be able to compare them with their R-squared values. So going back to the calculator then, go to stat, calculate. So we'll start with the quadratic regression, and we find out R-squared is 1. So it's going to be pretty tough to beat in terms of in terms of the exponential, but we will look at the exponential anyway just to double check. You'd almost think I planned this one out. The physics questions, if you're in a vacuum, they actually work out that accurate. It's just we don't have too many vacuums around here. So the exponential, do the exponential regression, and we find the R-squared is 0.93, so it's actually a quadratic. So you were asking last year in the grade 10 year as to when will you ever use quadratics in real life. Well, I've just provided you with 2 examples now. Whether you choose to accept that, that's another story altogether. So anyway, I'm just going to take a picture of that. So again, you'll have a screen that looks similar to that on a test, and you'll just fill in the information that's in front of you so that I can see whether you've entered it in properly. So again, it's going to be a quadratic curve. C part, I know it's quadratic. Quadratic. Because r squared equals 1, a perfect fit. And you're not going to find that in your project, unfortunately. It'd be nice to make your life a lot easier, but not always the way it is. So, D part, determine the equation. Well, the equation's right there. So the y equals, there's the a, b, and c again. So y equals 4.905 x squared, and then plus 0, you don't need to copy that out, where, and again, please identify your variables, where y is your distance fallen. Oops, make that a little bit cleaner for you. Distance fallen, that's in meters. And x is your time, and this time I think it was in seconds. Which leaves us to E. So this is just using your equation, and we let t equal 5 seconds. And what you're going to find here, the whole point was to see how close it was to the curve. Now, because it was a perfect correlation, when you plug this into the calculator, you're going to find that you actually end up with the exact answer. So 122.625. All right. So if this was more realistic, you're basically asking when you do an interpolation, when it's inside that range, you're testing to see how close your model is with the actual results. So therefore, distance is 122.625. So the only difference from previous lessons to this one is that you're picking nonlinear curves. Go through the homework. There's also an attachment that's on the website that you should go through because it gives you some other different curves to experience and allows you to do a bit of an analysis on that. All right, if you have any questions, you know where to find me. Good luck.